And now let's move to our last presentation. It will be from Dragonfly Energy, which is a partner from United States. And it will be his CEO, Denis Phares, who will do the presentation. Denis?
Thank you, Nina, and thank you to the Upcell Alliance for the opportunity. So we are Dragonfly Energy. We are an American battery company. And from the beginning, our focus really has been on electrode manufacturing. And although we really started from a fundamental manufacturing standpoint for cells, we also built a business pretty early on. So the company itself, I founded the company around 12, 13 years ago in Reno, Nevada. Part of the calculus there is that there's actually a lot of lithium in the ground in Nevada, and it's probably the most quick to be developed in North America in terms of extracting the lithium from the ground. We've leveraged this pretty early on by partnering with a mining company, Ioneer, that actually just recently got full approval to begin building the lithium mine about a couple 100 miles south of Reno, where we are located. But in terms of trying to establish cell manufacturing, this obviously takes capital. And so our general business approach has been to begin by assembling battery packs. So we make the modules, we make the cells, and we actually develop the markets and sold systems directly both to the aftermarket and to OEM customers, which I think ended up making us a more comprehensive energy technology company than we intended to be when we first got started. I mean, ultimately, we were really an aerosols company. We were a company that was interested in making lithium-ion battery electrodes from aerosol processes, and there's all kinds of benefits to aerosols in terms of manufacturing, in terms of manipulation of materials, which I can briefly discuss. But on this slide, we really find ourselves kind of at the nexus. We do the fundamental innovation and technology. We've got the analytical equipment to examine the production of coin cells and pouch cells, how the SEI forms, how the cells age, all of that stuff. Because you need that stuff if you're making a new manufacturing process. You want to ensure that it works. At the same time, our ultimate goal is to bring cell manufacturing to North America, and to do so in a cost-effective way so that we can compete on a global scale. You know, obviously it's cheaper to do things in other parts of the world, and so it behooves us to make some of these step function enhancements in manufacturing in order to compete. But what we've done kind of put the cart before the horse in some ways. We actually created the market for ourselves. So we created a line of battery packs, which we called Battle-Born Batteries, named after the Battle-Born state of Nevada. That's just the state motto. And we actually drove the market. So it was us that really brought lithium batteries on a mass scale to the North American RV industry. And RVing, for example, has historically extensively used lead acid batteries for the house storage. And we basically convinced the aftermarket, the retail consumer, of the benefits of using a lithium-ion battery, the safety associated with all that stuff. You know, it was a large education campaign for us, and eventually got the attention of the OEMs. So now if you buy an Airstream, if you buy a Keystone, a Tiffin RV, it has our battery packs on them. And we're becoming more of a full system integrator. So we assemble the battery packs in-house today from cells that we are purchasing on the market. But we're also producing the entire system that incorporates all of the charging, the alternator regulation, because when you're in a vehicle, you're charging from the alternator, all the downstream stuff, the inverters, the DC-DC converters. So we really do span a large swath of the industry. But coming back to the actual innovation, the cell manufacturing, I noted that we started from an aerosol process. So what we're doing is we're really producing electrodes from a dry electrode process. Now, we've been calling this dry electrode for some time. Today, the term dry electrode has come to mean more of an extrusion process, which is not an aerosol process. Ours is a pure aerosol process. It's an aerosol to film process. And our friends at Sphere Energy have come in and done a cost study for us. And relying on their numbers, you can see by eliminating the solvent for the NMP solvent from the cathode manufacturing, we already know from dry electrode efforts that this is going to create a significant, not just cost savings, but energy savings, because it's very energy intensive to evaporate a relatively low vapor pressure liquid like NMP from a film, from a tortuous micron nanoscale crevice laden film. It's hard to get the liquid out of there, and is often followed by another vacuum step. So what this means is you can save energy, but you also save a lot of space. When you're at scale, if you're evaporating a solvent from the film, that evaporation has to be done very, very slowly, or it simply doesn't work. You have mass transport of the carbon and the binder that can result in non-uniformities, and you can get delamination and all that stuff. So you have to evaporate slowly. At scale, what that means is you need a really, really long drying oven. So if you can decouple those two things, then it's possible to create a much faster deposition process, formation process, without all of that space, without all of that energy. So we've applied a couple of well-known processes. One of them, for example, spray drying, is very well known in the battery industry in terms of material formation. We actually use this to pre-prep the electrode grains. We can pre-distribute binder and carbon and other things on the surface of the electrode grains, the anode and the cathode. And by doing this, we can ensure, before even depositing anything, that we have a very good distribution and very good uniformity. The deposition is done through a powder coating process, an electrostatic powder coating process, and we've been able to develop a process that allows us to dual coat both sides of both the anode and the cathode foil simultaneously. And so by doing this, we can, in a very small space, in a very rapid fashion, uniformly deposit anode and cathode films. So if you compare to the conventional process, you're basically eliminating that NMP drying step and the vacuum drying step, and you're replacing it with a pre-coating step, either using a spray dryer or some other aerosol-based process, and then an electrostatic powder coating step. And then after the calendaring process, which can be done very quickly, the electrode is ready for fabrication. So there's really no other post-treatment that needs to be done to further evaporate the NMP or anything else that needs to be done to prep for cutting and slitting and winding, etc. So the rest of the process is relatively similar to convention, but that front end is a great thing to replace because of the cost savings and the space savings and the energy savings. And ultimately, it allows a gigafactory to be constructed in a more modular fashion. You don't have to go so big in order to really reap the benefits of economies of scale. So that really is the benefits of our type of dry electrode process. So I alluded to the spray drying process, which is obviously a very common process when it comes to food and pharmaceuticals, but also when it comes to lithium-ion battery materials fabrication. The nice thing about doing something new is you can explore things that you can't do with the old processes. For example, let's talk about a solid state electrolyte. It's very difficult to really layer different materials using a a casting process. An aerosol to film process is very, very effective at creating interfaces that are very high surface area and very intimate. So from let's say a composite electrolyte point of view, the typical aerosol processes can be applied to composite electrolytes. You've got both ceramic, polymer mixtures, for example. You've got salts in there, you've got additives, etc. But now imagine you're layering cells and you're layering materials, and you're doing it in a way such that not only is the adhesion with the foil very, very strong, but the interfacial surface area is very, very high, and that allows for low impedance to lithium transport. So of course we're applying this right now to the conventional cells that we put into our battery packs now. So we're applying the process because we already have the customers and we already have the market for conventional cells. So that's obviously where we're going to start, but the ability to apply these techniques to new chemistries, let's see how good a battery we can make. We'll start with a process that we know can scale, that's inexpensive, and then see how good a battery we can make. And that really has been what we've been trying to do as a company for a long time. It has to do with risk mitigation, and let's ensure that there's a market and ensure that we're keeping costs low and ensuring that we know we can scale. So for us, as an American company, particularly in the state of Nevada, where we have a lot of lithium, we fit very much into this local ecosystem where we are trying. There's a strong effort supported by the government, supported by the local government, to really try to keep things in-house so that we can innovate, but also scale without the risk of having to rely on others. So, it's obviously a large task in front of us. It's something that's important to us because we feel that self-reliance is, especially when it comes to energy, is very important. We hope that this can be done globally because ultimately we want people to have access to their own materials, to their own energy. And, ultimately we think that the future is looking very bright in that regard.
Thank you so much, Denis, for this introduction. Very exciting, and I hope you have a lot of good luck in the near future. So I hope that you will success a lot. And thank you again so much for your participation in this webinar and the introduction of Dragonfly to all our members. I'm sure that they are also happy to see your activities and what is these new steps.